Remember the general form for a quadratic equation was like this. Take this as our specific example. X squared plus 2x minus 5 equals 0. This left-hand side does not factorise, meaning that we could not easily express it as a product of two linear factors. This does not, however, mean that we are stuck when trying to solve this equation. The technique we use to solve it, which can be used to solve any quadratic equation, is completing the square. Here, we aim to express one side of our equation as something squared, and then take the roots to then solve the equation. The first thing we do is move the constant term over to the other side of the equation so it looks like this. We want to write these two terms in a new way, involving a squared term. When we have a squared term in algebra, say x plus 6 squared as an example, we expand out by multiplying x plus 6 by x plus 6. We will get an x squared and then two lots of 6x making 12x and a constant term of 6 squared, so it's 36. If we replace the 6 with a 4, we would then have 8x plus 16 instead of 12x plus 36. The 8 coming from the two lots of 4 and the 16 from the 4 squared. Since we want to replicate x squared plus 2x in a way involving a squared term, we would put x as the first term to guarantee the x squared when we multiply it out. And the number here would be such that two lots of it will give 2. Two lots of 1 is 2, so we put a plus 1 in the bracket. Now, when we multiply out this bracket, we will get x squared and a 2x as we desire. We will also get a plus 1 at the end, obtained from doing 1 squared, which we do not want. We correct this by subtracting off the unwanted plus 1 at the end. If instead we were trying to replicate x squared minus 6x, our squared term would have to be x minus 3, obtaining the x squared and the minus 6x when we multiply out, with the 9 to then be subtracted off at the end. Now we have written x squared plus 2x in this form, we can move this constant to join on to the other side of the equals. Now, x plus 1 squared equals 6, and so x plus 1 must be such that when it's squared, it makes 6. There are two values x plus 1 could be, so then when it is squared, it makes 6. And these are the square root of 6 or minus the square root of 6. Both of these would make 6 when they're squared. Now we find all x squared terms have disappeared, and we can just rearrange to work out what x is. This plus and minus refer to different solutions, but it is often easier to write it with a plus minus sign. In our example, the coefficient to the x squared term was 1. If it wasn't, and let's say it was 5, the first step would be to divide the whole equation by 5, so that coefficient is 1. Now we repeat the same process, the only difference being having to work with fractions instead of nice integers like we have before.